Okay, on the hunt for a Mewtwo right now. Specifically, these guys have been hunting the Mew for a while. It's been on the standard model for quite a while. We'll go back to here. This will G2 physics. Um, when you're kind of looking at the standard model, this again been around for a while. We know that from a post that I just put up of Physics Girl. I kind of was going through her information, and as she's describing it, what I'm trying to do is explain that geodesics. I'm saying the impossible Mew inside here for the feeds and speeds on something like this big bad puppy here that's actually like a couple of states wide. I don't know. She does a picture of it. These guys have watched this one from a while back. Here we can see the differential is 1 and 2 days, 4 days ago. In new physics, well, great for scientists. And I like to use that mechanics from well, you're gonna get there, and then there's Feynman diagrams right there, or electron. You can get into marshmallow general relativity where it's talking about, or special relativity where it's talking about negative E, or it's just a diagram. They're talking about the mu as far as what it is, and this is also a micro unit or a micro movement. It's kind of another substitute for Planck's constant in what it does, but here would be in the code generation of collisions or off of the Feynman diagrams in themselves, because this is basically going to be the reaction in, out. This could be the fuzz, this could be it, but in its basic subcomponents, we have a nucleus and an electron, right? And somewhere between there, there's a connection, a graviton, a muon. That could say the relationship between things. But again, I wanted to give you a little bit more down and dirty to earth version of what those kinds of diagrams. I'm hitting you with the book right now. Stock models, Weebles, droid systems. Those are essentially Feynman diagrams right here. As they're being broken down, step mechanics and derivatives, the equation matrix for what those bases turn into are going to be stone mill manuals. There's NP problems of the organization and position of what these are, but there's some basic standard models, some basic, 3 parts inside of here: triangulation, Pythagorean theorem, Fibonacci's Fibonoptics for economics. It's a graph inside of here. This box is a play button. So when I'm talking about it in as the definition for the post that I put up for actual her video, and what I'm talking about, I said I'm gonna go out and catch a Mewtwo just for funsies. We got so many of them running around out there. They're an invasive species for the most part inside of there. I'll take them up and fry it up, cook it for dinner. And given the math of how you equate things and do things, there starts to be a diagram for what that does. And again, I'll generally just we'll come back here, because my goal isn't to just get these. I've already have these experiments, so it's to catch it in a new form where I'm catching a vibration or a screwball kind of a thing when I'm talking about the wobbles in the account. That's a muon. We'll get back to that. Remember, we're talking about stuff you can actually experiment on because you built it. You can build it in there, but they are different. And in the same way to the stone mill. All right. I thought I already did it. Oh. Should come up in my search. Well, isn't that just a kick in the... Alright, well, anyway. Maybe now you like? Maybe now? There we go. Alright, so again, I'm not super proficient. I want to be honest with you. This was in the first realm of the area. I had some experience rock facing, but... Oh yeah, that noise. You hear it? That's muon. Not necessarily because it's making noise. I mean, at that point in time... Things are different when you're trying to cut it all down. You need some of that vibration. Vertical into linear. You want to get that spin going, got that flavor on it. You're gonna turn the sky purple. So again, I'm just practicing systems here, but because I know these things, and I'm just gonna keep this going off in the background because there's a task. The cut in itself is an X. But as you do those things, they correlate to, I mean, I would do a little different now. There's certain techniquing variables. What do they want? They want it rounded, so it's all rounded into the next stone, or am I just trying to, is this a corner I got to make sure I don't blow out because I'm hitting two edges? Yeah, there's a lot going on in there that are a mechanical move every single time. And if you're doing that right, you'll control that muon. If not, you're going to say that pitch, that move, this angle by hand is an internal hydron collider, and the result would be the action and EM field across this system. It gets in here. Eventually, I get a hold of that thing, and you'll hear the metal hit. One of them in here, I think it's somewhere over in here, but just keep it in context. This is an EM field of a beep, a beep, a beep, a blink, a blink, a beep, dropping a certain set of inches, I understand, so I should hear a few things. It should come up. It should go over. Those things would make perfect sense because there are operational models. There are, a lot of things that say, well, that's a particle. What's the difference inside here is how they quantify muon. That that glitch inside of the system. Ones and zeros, but not so much ones and zeros. You get a machine, you get it, and now it's you got it inside of there, but then there's the gas, the propane tank. Which version or which choice, given, well, obviously you can't have something unless it's, we're going to have to lose some kind of engineering thing here, which gives that grass type or whatever a differential inside of there. And this is going to be big for labor, union, biometrics. I could slide it into neurology, but this brain scan and neural net works a little different for matrices of pieces of paper that's a 6-inch step matrix. Well, here's going to be a 3-inch, 4-inch, or yeah, it looks like 2 or 3, 2.5. Tim, how you going, Tim? You watching me do? Yeah, I was setting up. I was burning for him while doing this. This was just an operation I come over because they wanted to test me on this, which really helps him out. So he was getting him. Randy over there, I'm finishing for him so he can push on the saw instead of run this. Keeps him inside for the winter. That's not my operation. I remember I'm just the helper monkey at this point in time. Chipping them across the floor. Sometimes you'll get a read in this rock, and eventually you'll learn to burn it. So the burn is why you do that. It also uniforms the flavor across to this, inside of what it is. But this is the job. People may not understand the rock facing parameters. They go into this. If you hit a seam, it blows out a corner. Because usually we're trying. Remember, there's a rough end on the edge of this. There's, something that says that come out of the mountain, not just, everybody's perfect on there that makes everything great. Not to mention the good stuff is going to be buried. And we're talking about blocks that are this size right here, where I'm looking for this one, for the premium, right? That's where the good stuff is. And meanwhile, the mountain face is up here, and this is just dirt and trees and everything. Something to consider about one of the wiring in the background, the photon running around. And somebody be like, yeah, well, unless you learn telepathy. And right there would be a lot of telepathy. There would be a look. So, you gotta get in there and kind of catch that variable, because this is definitely CERN. Things are moving, even though they're tractor force things, you wouldn't think about what this is. Believe me, that move right there hurts. That's one of the reasons your hands are hurting after the end of that. That's I think a 3 or 4 pound, it's somewhere between 2 and 3 or 4 pound hammer, depending on what you're doing. Sometimes the sets are wider, sometimes the hammer, you gotta get on it for 6-inch steps rocked, right? Get in it. I didn't do that. I've definitely seen the player getting it done right in this spot right here. And in that inverse shadow problem, always what was and kind of what that's going to have to be. You might disagree. You might not have no clue what the body technique on what that is. And you're just out here doing it. It's not like somebody they were here, and meanwhile. So that's what it is. You get the angle, you hit it with your, see, right there. Ping. Oh, eventually. And over the years, they'll chip in some stuff out of 4 feet sheets on forklifts and stuff like that. Eventually, you just hear the metal and you keep going. I mean, literally, you'll get on there with boulders, like boulders, stuff you'll see out in the backyard, stuff that's footage-wise like this. I've done it over to Gustin, and we'll split them. Me and Smitty over there, my boss man over there, training me how to be the wood rock. He's gonna get in there with that 4 pound. I forget what the name of the type of hammer it is there, and he's gonna just all the way back, hand on that thing, let loose, and you're gonna have to learn how to do that, Mason robot. You're gonna have to. That's the feeds and speeds and Higgs in this building about math, right? And I was like, well, you're gonna try and put that on there and cut that out of that, huh? You're gonna get that much out of this for your paycheck math, huh? Mew, meow, Schwarzenegger, multi-world. Well, like I said, these become calculus gatekeepers. These guys right here. I mean, in the set right here, you guys really are. That's that number right there. It seems like you wouldn't factor it, but that is how it is done. Now, to be fair, I can half that. If it was something I'd tell her to split it off the table, hit it with a hammer, break it. Now, if there was something up here that said that technique works, and then you went outside that technique just a twiddle bit. This photon from this direction to that thing and that mechanical action at the well, it looks like a 3-4 pound hammer right there coming at that angle against bone. Mythbuster. Tell me you don't see him sitting on that pallet watching me. I see you. Wait, come on. I can walk faster than this. I walk my granny, my dog faster. He's right there. Right there at that 45 between the 3, 4, 5 rule. Right there. Just looking at that angle, that nice curl right there. Alright. Mew. Catch you on the next one.